Welcome. Today we're excited to introduce Matt Marino. Matt is the owner of Prime Performance, a concierge rehabilitation clinic, health and human performance center, and Evolving Innovation, a consulting firm focused on workplace injury prevention and return to work services. Based in Portland, Oregon, Matt is a physical therapist, applied sports scientist, performance coach, and certified professional ergonomist. He's an internationally recognized expert in medical devices, exoskeletons, wearables, and assistive technology. As a founding partner of the ASTM International Exotechnology Center of Excellence, he contributes significantly to product development and industry standards. Thanks, Matt, for joining us and sharing your experience.
Thanks, Josh. Appreciate you having me on this podcast. It's wonderful.
Of course, I'm excited to dive in. So, Matt, you have a really unique perspective on this industry as a father, a physical therapist, and a developer. I'm wondering if you could share some personal history with our listeners on how you got involved in this industry to set the stage.
Yeah, sure. Happy to do that. Yeah, my background in education is in physical therapy and strength and conditioning, but about 12 and a half, almost 13 years ago, my first kiddo was born. He has cerebral palsy. So instead of probably, grieving that in the neonatal ICU at that time, I was searching on my phone and computer for technology and treatments and things like that that might play a role in his future and helping to improve his mobility and quality of life. And I kind of stumbled upon this whole space of exoskeletons, and my focus at that point was on medical exoskeletons for people with different types of injuries, illnesses, or in this case, a disability. At that time, going back almost 13 years, really all I was seeing was concepts, academic papers, research on products that were still in laboratory settings, not really commercially available, really designed for things like spinal cord injury or stroke that commonly affect more so an adult population, not a pediatric population too. So I continued to hunt for several years, and come around 2015, 2016, I saw an article about an exoskeleton for kids. Sudex was actually the company. They had won, I think, $1 million for designing a pediatric medical exoskeleton. So you bet my next step was getting on the phone, trying to call over there and see, like, okay, is this something that we could actually get our hands on and use? At that point, kiddo was getting to be, 3, 4 years old, so fits right into that pediatric category. But came to find out, like, no, it's really just a design. We don't really have a product. I kept in touch and sent them some measurements, and never really got a chance to have him try that product out. But the company did call me back when they saw that I was an ergonomics professional, because they had occupational exoskeletons, and they were curious if I had any clients that might be interested in trying them out and using them. So that's really where I got started working hands-on with different types of exoskeletons, was in the workplace with neurotypical population, normal workers, normal employees doing physically demanding work. And we were looking at the back assist and the shoulder assist devices that are probably most popular or most common on the market today. So that's the long story. That's kind of how I got into it, but then continued to do consulting project work in that area until 2019, when I made a transition over to go help Carl and Mark and Matt start up HeroWare. And then around 2022, stepped away and went back to consulting in the space.
Thank you, Matt. Very interesting history, and I didn't realize you and I started in the field of wearable robotics at around the same time. So I wanted to dig into the occupational exoskeletons a bit more since that seems to be your professional focus. Um, so, what are the main factors you see driving the adoption of exoskeletons? And I'm curious for your perspective, both as a developer and as someone who consults with users.
Yeah, it's a really interesting question, and I almost need to deconstruct it because adoption is a strong word, and I typically think of adoption when it comes to exoskeletons as continuous, ongoing use of the products. And I think we have some examples of that, but they're honestly quite hard to pin down.
Hmm.
Um, a lot of exoskeletons out there in the world. I'm not gonna deny that, but looking for companies that have implemented them well enough that their workers are continuously using them. Those examples are hard to find, and somebody please correct me if I'm wrong here, and write some articles about it and tell your story and get the word out there, because I think people need to hear those examples. They need to hear those stories, and especially some more information about the challenges that were faced and the things that you had to do to keep exoskeletons on people for their benefit long term. But I'll kind of come back and say that one of the driving forces for exoskeletons in the workplace is injuries. It's people who are in pain, and because of that pain, they aren't as productive at work if they're showing up at all. And because of that pain, they're quitting jobs and going and trying to find new work. And because of that pain, they're filing workers' compensation claims. And sometimes those get pretty expensive for companies and extremely costly for the workers and their families themselves. Nobody wants to be in pain. It hurts. And that is one of the big drivers, in my opinion. And one of the biggest reasons why I really got into working with occupational exoskeletons in the first place was that idea that I could scale how many people I could help. Because in the clinic, in the gym, I can really only help one person at a time, maybe a small group of people at a time. But by bringing products like exoskeletons that potentially reduce the risk and reduce that pain that people feel into the marketplace, we could get them on the backs of thousands, if not more, people. And that was my grand idea of here's how I'm going to really make an impact in my career, is by trying to help lots of people not have to come see me at the clinic, prevent a lot of back injuries, prevent a lot of shoulder injuries, wrist and hand injuries, or whatever it is, whatever the body part is that we're talking about. Um, that's the driver, I think, in my opinion, at least for a lot of the health and safety people that are entertaining the thought of bringing exoskeletons in the workplace. I still don't think the workers even know that exoskeletons exist for the most
Hmm.
part, outside of Hollywood films, and that's something that hopefully podcasts like this and other types of educational series will address. Like, we really need to get the word out there and increase the awareness of these types of devices and educate people on what they really are and what they can and can't do, and how they might be able to help and play a role in improving quality of life. But that would be my answer to that question, Josh. I hope that gets it for you.
It does. Thanks, Matt. And yeah, it was a pointed question on purpose because I feel like um, the adoption and the pizzazz around exoskeletons are not always aligned, and we need to get better at this. Um, so yeah, you must have really interesting perspective because you're working both on the treatment side as a physical therapist and hopefully on the prevention as well, as an ergonomist. So just following up on the last question, do you see the driving forces from both aspects of your professional work?
Yeah, and like this might be a good time for me to clarify. I work on both sides of exoskeletons, both the medical side and the occupational side. The clinic, our clinic Prime Performance, we do consulting work with medical device companies that either have a medical device or an assistive device that are trying to get those products onto people to help people who have medical conditions.
Hmm.
So think, devices that might augment grip force or hand function, devices that might be great tools for gait training in conjunction with formal treatment, of course. And we're able to help those companies screen and assess potential clients to determine if those types of products are appropriate for them or not. Help identify the specific products in some cases that might be most appropriate or best fits for those types of individuals. Help them with sizing and measurements so that they can place orders, and then initial trainings and follow-ups, troubleshooting, customer support type things. So on the medical side, we do that kind of stuff. But then on the occupational side, it's ergonomics consulting that really drives a lot of this, coming in, doing an assessment, identifying the primary risk drivers, and then the potential solutions. And we always like to start with engineering controls and solutions that don't even require the use of an exoskeleton, if possible. But there are so many jobs where that's just not a possibility. So these types of products can and do play a role in preventing injuries for physically demanding work where there's no other good solution, or at least no other good solution right now. Maybe there will be in a few years, and in those cases we might see exoskeletons bridge that gap. But using them both, I think there's a role to play on both sides, the medical and the physical side, for people like me and for these products, for these devices out in the world. I hope that answers that question.
Yeah, that does. Thank you for that perspective. Um, so you you mentioned in your previous response that a lot of workers don't even know about exoskeletons as a potential solution. And I think generally speaking, with exoskeletons and any emerging technology, uh, achieving critical mass is one of the big challenges. Um, just got me thinking. Do you see missed opportunities for direct to consumer type of marketing for these products? How do we get in front of all of those workers?
Yes, I've always kind of thought like the one of the better ways to get in is to get in with the worker. If a worker is going in to work and telling their manager like, "Hey, my back hurts and this thing would really help me do my job," I think that would be one way to get more exoskeletons into workplaces. But that just hasn't been the approach by the vast majority of exoskeleton companies. It's been mostly business to business type
Hmm.
sales where they're going in and trying to sell to the company and not to the worker, and that puts the workers in an interesting position sometimes when they're voluntold that they're going to wear an exoskeleton today, and they want to see, the company wants to see if it's going to be a good fit, and people are just like, what do you mean, like Iron Man? Like, what are you talking about here? And they don't really even know, and nobody provides them with any kind of education leading into that trial. And that's one of the things that on the consulting side, me and my partner Sarah Bellini Ross are trying to help companies change, is that approach to bringing these products in and helping the workers understand what they are even before they show up in the workplace, because the implementation starts, it needs to start, should start before the exoskeletons even show up. You got to get buy-in from all levels of the organization. You got to communicate about what you're doing. You need to educate and train people a little bit before the products even show up so that it's not a total shock and surprise, because we all know how people feel when somebody comes and says, "Hey, you're going to do this today, whether you like it or not." And like, what if you're the kind of person, and we've encountered these types of people, that they don't like to wear stuff. They don't even like tight fitting clothing, and you're asking them to put something super snug on their body that's going to push and pull on their body in different ways and be completely novel and unfamiliar to them. So there's there's a lot of work to do when it comes to exoskeleton implementation, and I think that's a big challenge. I hope that answers that question too.
Yeah, for sure. So earlier you mentioned that there are a small number, but some number of success stories so far in adoption. Um, I don't know how much you can share, but I'm curious to understand a little bit more how you analyze the return on investment or the cost benefit of products like this. I imagine if there are stories where, you know, um, usage is starting to become self-sustaining, have we been able to measure benefits yet? In a purely economic sense, for those employers worried about their workman's comp claims?
To my knowledge, there's been a handful of, we'll call them studies, but they haven't really been, peer reviewed. It's not that kind of study. It's,
Mm.
The company and the exoskeleton vendor collaborate on a project to measure impacts on productivity. And in the handful of examples that we have, and I can only assume that we're going after really good slam dunk type use cases and potentially cherry picking on the data, but I don't want to accuse anybody of anything. Like what I know is that you have to first of all have a job that there is a productivity measure for, because if it's like a job on an assembly line, like there may not be a way to increase the speed of production. It just is what it is, right? So with ROI, I'm going to come back to that part of your question. One of the best ways to prove that there's a positive return on investment for exoskeletons is going to be with a productivity improvement or a work quality improvement, which leads to less rework of product, right? So where you can measure those things, that's a really good way to prove that the cost benefit is there. Because if you're just looking at injuries alone, it's hard to say how many people, let's say you have a population of 100 workers, it's hard to say how many out of that 100 are going to get injured in the ways that the exoskeleton can potentially prevent. It's hard to say how much those are going to cost. You can look at averages over time, or you can look at industry averages, things like that. But that's if you look at ROI calculators, and there are some out there. Like I use one from the Washington State Department of Labor and Industries. Some of the exoskeleton companies have ROI calculators on their websites. Some are better than others. But if you start looking at those and you start running your own calculations, if you're talking about a job where there is some ability for the employee to change their speed of work or their performance output, then you can start to measure these types of things, and you're going to want to measure them for some period of time before the exoskeletons show up so that you have a baseline. And then some period of time after the exoskeleton comes, and you probably want to do this for over a month because initially there may be a slowdown as people learn to use the exoskeletons, as they have to step off the line for training, troubleshooting, fitting, adjustments to the devices, things like that are bound to slow things down. So you don't necessarily want to compare those first couple of weeks of exoskeleton use because you might not see what you're hoping to see in the productivity. But then as soon as people really start to get a hang of things and the devices become more integrated into the workday and things are taking less time for people and they're able to just throw on their product and get out there on the line, then that's when you might start to see some increases in productivity. And if you're going to prove that a product is worth its cost for a large population of people, not all of whom are going to get injured, that's the best way to show it. Now, of course, I'm not saying that people who are given exoskeletons should be expected to speed up their pace of work. If they do so, then the logical question is, well, are the exoskeletons, is that productivity increase negating the benefit of the exoskeleton? if you look at tools like ExoLift, you can run models yourself and see that no, people are probably still getting the benefit of the exoskeleton, even if they auto-regulate or self-select to work 5 or 10% faster or be 5 or 10% more productive. But that's really going to be the best way, and it's not something that's going to be measured overnight, right? You have to start again before the exoskeletons even show up, and you have to continue for a period of time after, which means that people got to consistently use the products, and turnover has to be kept to a minimum, because otherwise you have to reassign those suits and start from square one again with people. So these are not easy things to do, which is why these partnerships between exoskeleton companies and their end user companies are super valuable for everybody, but not something that's just slam dunk easy to do. It takes some work and it takes some investment, and that has to go into that ROI calculation. It's not just the cost of the exoskeletons, it's also the cost of your staff and their time, outside consultants or experts that you need to come and help you do these things well. Because if you don't invest in implementation, there's a good chance that you're not going to be successful.
Very interesting. It seems like the argument is a mix of maybe traditional robotics that would be used on the factory floor to automate tasks, and PPE, which is keeping workers safe. It's not just one or the other. It's sort of a hybrid of both. Carrot and stick may be motivating factors. I hadn't thought about it that way before.
Wearable tools. I mean, exoskeletons really are tools. In some cases, they may be classified as personal protective equipment, PPE. Like, we have to be careful around that though, because as soon as you say, okay, we have a hazard in the workplace, you're doing a job safety analysis in that case, or a job hazard analysis, and you're saying there's a hazard here, and the exoskeleton is the control for the hazard. Now you're legally required to provide one to everybody. And we haven't even started to talk about fitting these products on people, but what if you have people who are either too big or too small to fit in the device, or what if it's just not comfortable for everybody and people refuse to wear it? Like, now you have a potential problem on your hands, because you've said this is the control for this problem, but not everybody can wear this. So do you start reassigning people to other jobs? Like, there's a lot of things that need to be thought through on that end of things, Josh.
Wow, that's a great insight. I hadn't thought of it before. Yeah, so generally speaking, exoskeletons are being used to address relatively low hazards, I have to imagine. But yeah, even classifying as a hazard at all could be risky.
Potentially, if you go as far as to say the exoskeleton is the control for it on your legal documents, like your JSAs or your JHAs, whatever you call them as a company. You may identify that manual material handling, lifting, pushing, pulling, carrying, something along those lines, gripping, is a hazard, but you might not put the exoskeleton as the control on the document, so that you have a little bit of flexibility to try to figure out what that is. So this is like a whole can of worms, as you can see, conversation that we could potentially open Pandora's box about a little bit here. But yeah,
Well,
there are legal considerations.
I mean, for clerical work, right? Typing at your computer is a hazard for your wrists.
Yep.
But no PPE is prescribed.
Nope. An ergonomic keyboard, maybe. Training on how to, properly, key using the keyboard. Things like that. Those classic like ergonomics things would be put in as controls on that. But if in the future there's an exoskeleton that can make people type safely and not get carpal tunnel syndrome or whatever, then you might see that. But you also have to prove that these things are personal protective equipment. I know in the EU there's a different standard if you're gonna if you're going to certify if you're going to get your CE mark under the machine directive versus personal protective equipment, there's different requirements and different burdens of proof, let's just say, to meet each of those or to hit those bars.
Hmm. Okay, interesting. Well, moving on a little bit, you've mentioned a few barriers to use and adoption. Um, Maybe if there are others you haven't mentioned that you could touch on, that would be interesting. But I wanted to ask, how should a prospective user or buyer prepare themselves for successful integration?
Does this potential user or buyer know anything about occupational exoskeletons? Would be like my first question.
Let's say
There's
yes,
a
because solving the other
okay,
problem is more
okay.
complicated.
There's a lot to consider here. There's a group in Europe that's done some really good research on this and published in peer-reviewed journals on factors that contribute to the acceptance of exoskeletons in the workplace. And secret sauce here, but we definitely use that work as a basis for our approach. We approach this stuff systematically. So we're going to be looking at, implementation related factors, work related factors, policy related factors, um, psychosocial factors, and physiological factors. And there's several within each of those buckets. But that would be my recommendation is if you know what you're doing, then start writing your plan and make sure that you incorporate all of the things that you need to check and all of the pre-work that you need to do to overcome what are known to be barriers or thought to be barriers at this point. And if you don't know what those are and you don't know how to find that information, then there are experts out there that are happy to provide consulting services in those areas, and I would highly recommend those. So, selfish plug right there.
Yeah, this is a good plug for evolving innovation, but maybe we
Yeah,
can also
like,
put some links in the show notes to the
that'd be
group you
great.
mentioned.
Yeah. Yeah, we
Um,
want to help people. Like, we really want to help companies and ultimately the people that need these types of products be successful. And it makes me sad when I see people repeating the same mistakes that others have made for years and years and years that are known to some of us that have been working in this space for a long time. But I don't blame anybody who's new to this area for doing that. But I would just say, allocate some of your budget to some expert consulting, and it will save you countless hours and dollars.
yeah, for sure. Um, so one, as a developer, I thought one example I could bring up is considerations around sizing. So obviously, if you're bringing a wearable product to market, you ought to think carefully about how you can fit the widest range and variety of people possible. But with exoskeletons needing to be flexible, needing to be minimalist, and there being high cost of development, this is often much easier said than done. Um, so I was curious if you could speak from experience about, maybe some strategies you've seen that have worked well with regards to sizing. Um, One size fits all being totally impractical and likely to flop, and perfect customization being impractical because of cost.
Yeah, it's such a tough one to solve for, and the best advice that I could give if I'm giving producers advice on what to do here, it's go and talk to your intended users and go and talk to the people who are going to buy the products too, because in a lot of cases, especially the occupational setting, it's not going to be the workers that are buying the suits, it's going to be their employer. So you need to really cover your bases there and talk to everybody and see like what are their preferences, because that's going to become part of your requirements when you're developing on the engineering side. What we see out there at this point is, like you said, there's like one size fits most, which we know that there are major flaws there. There's no way one size is going to fit the entire spectrum of potential users. So what we've seen in other cases is that there's a couple different sizes. There's like a small, medium, and then a large, extra large, and now we're getting like a little bit better. And then there's a third approach that we see some companies take, which is like a modular approach. And now let's say you have three major components that can come in different sizes. You can mix and match those different components to fit the largest possible percentage of the user population. And that was the HeroWare approach. I mentioned that I worked for HeroWare for a few years earlier, so I'm happy to repeat that here, but I'm not with HeroWare anymore, so I'm not speaking on their behalf, and I don't want to be taken the wrong way here. But with the first Apex, that's what we had done. We had a couple different sizes of female specific cuts on shoulder straps, like on the backpack component of the product, and a couple different sizes for males. We had several different sizes of elastic bands that came in different lengths and strengths, so 3 different strengths, 6 different lengths, and we had 3 sizes of leg loops, thigh sleeves, whatever you want to call them. I think the new Apex, if you've seen it takes a similar approach on the modular sizing, and I still believe that that's one of the better ways to fit a large percentage of potential users. But there are some out there who shy away from purchasing a product because of the modular approach and the challenges that potentially presents to implementation when it comes to having to figure out what size everybody is and fit everybody and making sure that you have all the components. And then what happens if somebody leaves and somebody new comes and they need different sizes or strengths of components, and it can get pretty challenging if you don't have staff dedicated to the implementation of the product. So if you kind of are one of those people that expect the exoskeleton to implement itself, which is really not realistic, but there are people out there that think that should be the case, modular makes it a little bit more difficult. And that's definitely been lesson learned by me versus, looking at some of those other examples of, if it's one size fits all or most, then, hopefully your people can fit in it. If there are a couple different sizes, usually it's pretty easy to figure out who's in one size and who's in another size. But fitting and sizing, I can't stress enough how important this is, because if you want to get the desired benefit out of the product without having the most unintended consequences of a poor fit, it's got to fit well.
Yeah, I can echo your comments about modularity. That's definitely been our focus at Humotech. In the beginning, out of just practical reasons, we focused on a kind of one size fits as many as possible. And while that's okay in the beginning, I started to get a lot of feedback from customers that, and this sizing is just way too limiting for us, and we're having to exclude people who would like to be able to use the devices. So we took that to heart and have, developed modular systems. But it does add complexity, and that's really not ideal when you're trying to incorporate something new and novel. So yeah, maybe someday we'll have magic auto adjusting exos. So I wanted to bring it back to medical applications, a topic near and dear to both of our hearts, and thought maybe you could, for our listeners, compare and contrast how you see the medical and occupational domains in terms of state of the industry and what maybe we can learn from each other.
Good question. It's a hard comparison to make. It's one that I think about a lot, though, because on the medical side you have people that really need these things, right? It's the why for wearing it is so powerful. Whereas on the occupational side, like, you might have some people that have had a previous injury or that have chronic pain, and when they put on the exoskeleton, it really helps, and they have a powerful why. Very similar, right? but there's a huge population of employees, workers out there that nobody thinks they have a problem until after they have a problem, until they're in the physical therapy clinic, right? So there's just not a ton of motivation for some people. Think you're bulletproof, indestructible 20-something working in a warehouse lifting bags of dirt or dog food or something like that hasn't injured their back yet. They don't know what that feels like yet. So there's really very little motivation to wear this contraption around the workplace and get made fun of by their coworkers and stuff like that. So it's challenging to compare the two, because I think of these things as like, there's a why for wearing it, and then it has to be enjoyable, hopefully to some degree, to wear it. You have to get something out of it, and there has to be as little friction as possible. Otherwise, people aren't gonna do it. On the medical side, like, there's a very powerful why. They help people do things that perhaps they're not able to do without them. So there's that enjoyment, and you can kind of get over the friction when those two are big enough. But companies are doing a better and better job of making exoskeletons easier to put on, take off, clean, take care of, making them more comfortable, etc. So that's very powerful for putting exoskeletons on people and keeping them on people, keeping people using them on the medical side. On the occupational side, you have to weigh those factors. Like, why do I want to use this? Is it enjoyable for me to wear or not? And what are the friction points? Is it stored close by? Is it my responsibility to keep it clean at the end of the day? Do I have to keep readjusting it after somebody else is using it? Is it hot? Is it comfortable to wear? Those friction points that, maybe not all of those pieces are in place enough for the equation to net, like, yeah, I want to do it. I want to wear it. So it's really hard to compare the medical and the occupational devices out there and the need for them. I think we're going to start to see some crossover. I wrote a standard recently for ASTM F48 that got published on using exoskeletons for return to work. And these would be any type of exoskeleton technically, but the idea really, its genesis was in using occupational exoskeletons to help injured workers come back to work. Like, let's say somebody injures their back and they're on restricted duty, but they're able to come in and the employer's carved out some work for them to do. And let's say normally they have to lift 50 pounds, but right now the doctor says they can only lift 20 pounds. Okay, well, here's the aisle with the 20-pound items. You're going to go out there and do that work today. And here's a back exoskeleton to give you like an extra layer of protection, if you want to think about it like that. And that process is out there now. So we're starting to see more and more that companies are interested in using occupational devices for these workers' comp, injured worker type cases. And then also on the medical side, you could think of it like this. There are therapists, nurses, people that are providing healthcare that could benefit from some of the occupational devices too. But there's not going to be a ton of crossover there, I think, where maybe you'll see an accommodation, like an exoskeleton that helps somebody walk, to be able to come in to the workplace and be used as part of that return to work type process or accommodations process too. So I do think we'll start to see like a little bit of crossover between the medical exoskeleton space and the occupational exoskeleton space, but it's still pretty early for all exoskeletons. And you have some people that are highly focused on using them just for injury prevention and occupational purposes only, and then you have others like physical therapists that work in rehab centers that are interested in just using these products for rehabilitation and gait training type purposes, and not a lot of people kind of trying to take them and mush them together or look for opportunities where there might be some crossover. I think that there's a lot of potential there, but there's also like a narrower window for using these things. So for example, on the return to work side, if I got somebody with a back injury and I'm trying to help them come back and they have those restrictions and they like the exoskeleton, but there's something about it, like it's pressing on the part of their body that actually increases their back pain, like that might have been a good solution before the injury, and it might be a good solution once they're feeling better, but maybe right now during the healing process, it's not quite working out like we hoped it would. So there's some examples that we'll run into like that, which I've run into in the past. So I hope that answers that question. And I hope that the two sides can really learn from one another, because there's a lot of technology out there. And I think there's a great opportunity for designers, developers, engineers to look at other companies' products or to look at other companies' designs and take something away from it. There's a lot of really smart people working in this industry and in this space. And if I was an engineer, I'm sure that I would be able to learn something from every single exoskeleton that I saw or took apart. You know what I mean?
So, yeah, really interesting. At Humotech, we've been really intentional. We're focused on the early stage R&D of these technologies.
Yeah.
And in R&D, we don't have to define a difference. And that is freeing. To us, we're augmenting mobility. And that could be translated in many different ways to many different potential application areas.
Yep.
But I want to dig into this. I'm realizing I don't think I understand. What is the difference between an exoskeleton for return to work? Presumably there's an injury, and a medical exoskeleton.
There may be no difference, because it may be a medical exoskeleton that is the device that is needed to help the person return to work. But the genesis of this idea was taking an occupational exoskeleton, like a back or a shoulder exoskeleton, that really was designed for injury prevention for those body parts, and putting them on people who have injured those body parts because of the demands of the job, and the exoskeleton can help with it. So coming back to the back example, because I've used this several times, like you bend over, you lift stuff, you have back pain. You filed a claim, your doctor gave you some restrictions, your employer found some work for you to do, but you're still trying to heal. So going out there and bending over and lifting stuff all day long is probably not going to be the best thing for that healing process. But the restrictions are what the restrictions are, and you want to keep your job, so you go out and do it. But imagine if you could reduce the amount of force and strain going through your back, your spine, and your body by using this exoskeleton. And imagine if it makes those bends and lifts feel a lot better. It seems logical that it's adding a layer of protection there, so that your body is it's accumulating less strain and fatigue over the course of the day. So there's more resources available at the end of the day to go to sleep and eat a good meal and rest and recover and heal. Like you haven't broken your body down as much, because you've been protected by the exoskeleton. So it allows the area to heal more than it otherwise would have. And I've seen this done successfully many times. And I don't know if you've ever put on a back exoskeleton when you tweaked your lower back, but in my experience, it helps for a lot of things that you might do in those conditions or in those situations, right? So that's how I would say, like, there may be no difference. It might be that you are using a medical exoskeleton with a certain type of worker, certain type of injury, illness, disability, whatever it might be, to help them come back to work. Or it might be that you're using an occupational exoskeleton for a totally off-label use, because these things they're not treatments for injuries, and they're not technically something that a doctor can prescribe. They're not FDA approved or regulated in any way. So, you really need to have a multidisciplinary group of people, a team that includes a physician, that includes your nurse case managers, your claims adjusters, your ergonomics professionals, therapists, exoskeleton specialists, that work together to identify these are the appropriate cases, and then work with the employees just to make sure that you're doing the right thing for them and that it goes well.
Very interesting gray area in
Totally.
exoskeleton development. This is an area of use that I think is most interesting. When there's an injury, it amplifies that why, why use the
100%.
exoskeleton, because I'm experiencing pain. But yeah, there isn't the full level of, um, I don't know, mobility challenges associated with exoskeletons for people with permanent disabilities.
Totally. And we're going to see these consumer products now that are like in between too. It's maybe for the lower body, something that can help you as you're, let's say, aging, to be able to keep up with your grandkids or go for a longer hike with your kids. And your knees hurt usually, but you wear these products and magically your knees feel better and you could walk extra miles or you could ski for a few more hours or whatever it is. There's going to be this gray area and it's going to become more and more common, I think, as more devices hit the market in that like consumer everyday use type space.
Yeah, and I think physical therapists are ideally positioned to be change makers, um, and not often appreciated enough. So thank you for being on this podcast, and that's part of the story I want to amplify. Um, are these are the occupational and medical use cases? Well, I guess there are two kind of branches of physical therapy in training and in practice, right?
Yeah, yeah, you could think of it that way. Hmm.
Um, okay, yeah. Um, it's a little bit like selling people on diet and exercise. Um, sometimes the things that we need to like be healthier and get back on our feet are really simple, and just not the option that we like are likely to grab off the shelf and like integrate into our daily lives. Um, I don't know, just a random personal example. Over the years, I've developed occasional plantar fasciitis. Um, and though this has happened a few times, I'm surprised every time by how effective replacing the insoles in my shoes is. Um, I don't have anyone telling me to do that, and I seem like I have a hard time remembering to do that, even though I work in the industry.
Yeah, totally. And, hopefully some good physical therapy too, so that, you get to the root of that problem. It's great that the insole is helping to reduce or eliminate the pain when you get those flare-ups, but I bet a skilled clinician could probably find some other things that may be contributing to that would make the need to change your insoles out go away or at least be minimized. You know what I mean? So that's what we do in the clinic. Like that's definitely the clinical side of what I do at Prime Performance. But
Hmm.
one day, there will be some kind of fusion of this where physical therapists know about exoskeletons, let's say for workers, and they're treating in a clinic, and a worker comes in and says, "I hurt my back smoothing this concrete today, and I don't know if I'm going to be able to go back to work because of it." And the therapist can say, "Hey, look, here's a catalog of." I mean, this is all on Exoskeleton Report, but nobody knows about that website
Mm-hmm.
when it really comes down to it. Like, here's a catalog of back exoskeletons. These ones are the ones that you can order off of e-commerce websites, and this might really help you. But bring it in for a therapy session. Let's put it on. Let's try it out, and let's see if it works. So I think there will be a place for that kind of work for therapists in the future. But in the meantime, hopefully more exoskeleton companies will hire physical therapists or just movement experts, people that really get how human beings move in all the functional and dysfunctional ways that's done, because I think it would really help improve the fit, comfort, design, effectiveness of these products.
Hmm. Well, thank you for that good personal call to action. I should go see someone about my feet.
You should.
But I'd like to invite you to come visit us in Pittsburgh sometime. Um, But for our listeners, I was hoping you could share a call to action about how to better engage people with a physical therapy background into exoskeleton development. I'm in rare company right now. These conversations don't often happen.
Yeah, I love this question. Here's where I'm going to go with it. There's a lot of physical therapists out there who are working in clinics and just like it's like a factory. Like they don't even have enough time to really do physical therapy with people because it's unfortunately like one of those industries that's really driven by like insurance and whether or not there's insurance coverage. And then there's a business model there where clinic owners have to have physical therapists seeing as many people as possible in a given hour. And there's a lot of care getting like punted to unskilled physical therapy aides like exercise. And like in our clinic, like we do hour-long one-on-one sessions with the therapist. We don't have aides. So the therapy is a combination of all the things that people think of therapists doing, like manual therapy, plus movement and exercise. But the quality of the movement and the exercise and the approach there is really important. So there's a lot of therapists out there that really aren't happy with their job and sort of the factory PT approach where they get 15, maybe 20 minutes with their patient. They never even see them exercise because the aide's taking them through the exercise program. And then, we wonder why people don't get better all the way. And I think there would be a ton of PTs out there who would love to go and work on exoskeletons, designing products that can, like I thought, scale their impact and help more people, because most people get into physical therapy because they want to help people, right? So I think there are a lot of PTs out there that would love to work with exoskeleton companies, and I think there are plenty of companies out there. I think last time I checked, Exoskeleton Report is up over 150 companies out there that would really benefit from having a PT on staff to look at the products, look at how people move in them, to work with the people, with them, identify R&D opportunities, identify how to best get these things implemented, raise awareness, educate, you name it. PTs are people, right? And they're good at working with people. And I think one of the most important things that exoskeletons can do is work with people, put products on people, user testing, listen to your customer. And PTs would be really good at that. Plus, they have a lot of technical expertise in movement and correcting it or optimizing it. So please, exoskeleton companies, put out job postings and include PTs as good potential candidates for them. And if any PTs are listening to this right now and they're not happy with the work that they're doing in the clinic and they can't seem to find anything that really fits or jives with them, and exoskeletons sound like something really fun, and they are to work with, look for opportunities out there, because it's not something that I ever would have predicted myself getting into, but I'm grateful every day for the experience that I have, and I wouldn't replace it with anything as far as my career direction has gone. It's been really fun, and it continues to be really fun, and I look forward to many more years working with people, helping them in the clinic and outside of the clinic with all different types of technology, exoskeletons, medical devices, whatever that may be.
That's awesome. Well, the easiest thing to do is reach out to Matt Marino, and he'll help you figure out where you need to go.
Yep.
Thanks, Matt. Enjoyed the conversation.
Thanks, Josh. Yeah, this has been really fun. Thanks for having me.
Have a great day. Bye.
You too.